Questions 21 through 25 on the 2014 Grade 11 Fermat Math Contest. A bin contains 10 kilograms of peanuts. 2 kilograms of peanuts are removed, and 2 kilograms of raisins are added and thoroughly mixed in. Then 2 kilograms of this mixture are removed, and 2 kilograms of raisins are added and thoroughly mixed in again. What is the ratio of the mass of the peanuts to the mass of the raisins in the final mixture? So initially, you've got 10 kg of peanuts, right? And then what they do is they remove 2 kg of peanuts, which leaves 8 kg of peanuts, and then they add to that 2 kg of raisins, so 2R now. And the total is 10 kg. And at this point, they're removing 2 kg of this mixture. So they're removing 2 kg of that 10 kg. So they're removing 1/5 basically. So even though they're all mixed in, we can still look at it from the perspective of raisins and peanuts. So if you're removing 1/5 of the raisins, you will be left with 1.6 kg of raisins. And if you're removing 1/5 of the peanuts, you'll be left with 6.4 kg of peanuts. And then to this mixture, again, they're adding 2 kg of raisins. Okay, so now they're saying what is the ratio of peanuts to raisins in this mixture right here? Well, the peanuts is 6.4 and the raisins is 3.6. So that's what? 64 over 36 if you multiply top and bottom by 10. This is 32 over 18, which is 16 over 9, and that's in lowest terms. So 16 over 9 is choice E. Jillian drives along a straight road that goes directly from her house to her grandfather's house. Some of this road is on flat ground and some is downhill or uphill. Her car travels downhill at 99 kilometers an hour, flat ground at 77, uphill at 63. It takes Jill 3 hours and 40 minutes to drive from J to G. It takes her 4 hours and 20 minutes to drive from G to J. The distance between G and J in kilometers is... Well, let's draw a little diagram. So we've got J and G. And I don't know the distances, so I'll just say from here to here is the flat. And then the distances, I really don't know. But we'll just call them X and Y, the next couple distances. And we'll just say that when she's going in that direction, the flat is obviously going to be flat in either direction, but this will be downhill and this will be uphill. But then when she's going back in this direction, this will be downhill and this X will be uphill, right? I mean, obviously. So let's look at this scenario first, and we will look at J to G. And of course, throughout this question, we're going to use that formula, speed is equal to distance over time, and any variation of that formula, such as time is equal to distance over speed. All right. So J to G, this one, we're going to look at the time. The time is 3 hours and 40 minutes, so that's 3 2/3 hours. And that is going to be F over 77 plus X over 99 plus Y over 63. And then in a very similar way, G to J, if you look at that, it's 4 hours and 20 minutes, so that's 4 1/3. And that is equal to, again, F over 77 plus, this time, remember, this is now downhill and this is uphill, so we got to make sure that we don't mess that up. So it's going to be Y over 99 plus X over 63. So we can call this equation 1 and we can call this equation 2. So if we equate this now, I think we are ready to do some algebra here. 1 minus 2, I think that will help. If I do that, let's see what I get. I get 4 1/3 minus 3 2/3. And then on that side, I will get x over 63 plus y over 99. And then minus x over 99 minus y over 63. And then the f's cancel. This guy cancels with that. So if I collect like terms, this just becomes 2/3, and then I'm going to have to use some fractions here to get common denominators and all that. 99x minus 63x divided by 99 times 63. And then for the y, similar, 63y minus 99y over 63 times 99. That's going to be the common denominator there. So now I can cross multiply, and this is going to give me 2 times 99 times 63, and this is going to give me 3 times 36x minus 36y. Yeah. So that means if I factor out a 36, all I'm left with is x minus y, 3 and 36, and this side is the same. And then now I can easily isolate for x minus y. And when I do all that math, 2 times 99 times 63 divided by 3 times 36, x minus y is going to be 115.5. All right. So that's a pretty good result so far. But I am asked to find the distance from G to J or whatever. And that distance, if you remember, was f plus x plus y. Now, how am I going to figure that out? Well, I can use one of the original formulas that I had up there, that 3 2/3 was equal to f over 77 plus x over 99 plus y over 63. This helps me out a little bit. So let's see what I can get with that. I can substitute for x, I can substitute 115.5 plus y over 99. And that's going to be like this, 3 2/3. Okay, so now we got to do a little bit of algebra here. We got to get some common denominators and all that. So let's do that. 3 2/3 is equal to f over 77. Multiply top and bottom by 63, 115.5 plus y. And then multiply top and bottom here by 99, so we get 99y. And this gives me a common denominator of 99 times 63. So this, when you expand it all out, it gives me 7276.5 plus 162y over 99 times 63. And I'll break it up this time since I can bring that over to the other side. And this is 3 2/3. So now this is a number, so I can just bring that over to the other side. And when I do, and I subtract it from this, interestingly, it gives me 2.5. So that's a nice number. And all I'm left with on this side is f over 77 plus 162y over 99 times 63. Okay, at this point I still have two variables, but I can use inspection now. So let's see. Using inspection, let's see what I get. Because that's the only thing I can do when I have two variables. Let's say I let f equal to 77. That would make that 1. Okay, so that would be 2.5 is equal to 1 plus 162y over 99 times 63. Bring the 1 over and I get 1.5 is equal to 162y times 99 times 63. And if I solve for y in this, I will get y is equal to 57.75. And now, I kept this in the screen for a reason. We can use that to figure out x, and when you plug y into there, you get x is equal to 173.25. All right, well, now I can go back and figure out what is d. d is f plus x plus y. This is f, this is x, and this is y. And therefore d is equal to 77 plus 173.25 plus 57.75, and that is equal to 308. And there you go, that's the distance. So, number 22, the answer is C. Triangle PQR, PQ is 150, PR and QR are 125, as shown. 3 line segments are drawn parallel to QR, dividing PQR into 4 sections of equal area. The height h of the bottom section is closest to. Let's label as much as we can here. This is going to be 150. This is 125, and this is 125. And that is broken up into 4 equal areas. So I'm going to have to call some bases and some heights. So what I'll do is I'll draw one big height top to bottom like that. That's perpendicular to that. And let's start labeling some heights. So the biggest one top to bottom like this, I will call H4. And then the one that is going, I guess, just to this part right here, I will call H3. And then the one that is going to that part is H2. And then this one just from there to there is, I'll just call H1. So I hope that makes sense. Okay, so what we are basically being asked to find is find this little h right here. Well, that little h, according to my labeling, is H4 minus H3. Correct? So that's basically our goal in this question. Now let's do something to figure out what is the area of that entire triangle. Well, the way they drew it is that they actually have an isosceles triangle, right? So if I were to draw a perpendicular from that side to, let's say, the other side, like that, so that's perpendicular, what that does is chops the other half and in two. So this becomes 75, and this becomes 75, like that, this and this. So I can easily figure out this using Pythagoras. So if that, whatever you want to call it, this PQR, let's just say this is S. So SR squared plus 75 squared will be 125 squared using Pythagoras. And therefore, SR will be 100 when you do that math. So that means I can easily now figure out the area of that triangle, that big one. Area is 1/2 base times height. If I use the base as 150 and the height SR, which I just figured out, the area is 7,500. So that's very important because those 4 sections of equal area now each have 7,500 divided by 4 as their area, which is 1875. All right. So we can now easily figure out H4, that top to bottom. Since we have the area, and that's equal to 1/2 base times height, the bases, I'll just keep it simple. I'll just call this base B4, this base B3, this base B2, and this base B1, like that. So the area is 1/2 base times height, B4 times H4. Area we just calculated as 7,500. B4 is 125, and H4 I can now calculate. And when you do this math, you get H4 is equal to 120. So that means this question, H is equal to H4 minus H3. Well, H4 I just figured out was 120. So now all I have to do is figure out H3, and I will have solved the question. So that is my goal now, to figure out H3. Now let's turn our attention to the areas, those 4 sections of equal area. The first one is, of course, this guy right here. The next one is this one. The third one is that one. And the last one, of course, is the bottom one. So I will denote those as A1, A2, A3, and A4 for the corresponding heights and bases. And all of those are equal to 1875, right? As we had figured out right here. Now we have to figure out some formulas, but it shouldn't be that hard. A1 is just 1/2 base times height, which is B1 times H1. Right? A2 is 1/2 base times height, so B2 H2 minus A1, right? Because it's not the full triangle, it's just this section right here. In a very similar way, A3 is going to be 1/2 base times height, but using B3 and H3. But then, of course, I've got to subtract A1 and A2. And all of those are equal to 1875. All right, so let's start trying to figure out each of these. So the first thing, of course, is we need to figure out one of these. So we'll take it one step at a time. Let's just start with the very beginning, this guy right here, B1 and H1. Well, we're going to need a little bit of help, of course, because we have 2 variables, and when we set them equal to 1875, we have to solve for 1. So we have to get some sort of relationship, and that's where similar triangles comes in. And similar triangles, you can use the fact that if we have this triangle, it's similar to that triangle right there. So using similar triangles, B1 over H1 is the equivalent of 125 over 120, right? Where this is 125 and this is 120. And therefore, if we reduce this to lowest terms, we have that B1 over H1 is 25 over 24. So that means that B1 is equal to 25 over 24 times H1. And now I can use this and this to figure out my value for H1. So I've got 1/2 base times height. 1/2 B1 H1 is equal to 1875. 1/2, well, B1 is going to be 25 over 24 times H1, 1875. And don't forget, I've got to put in another H1 in there, right? Because it's H1 times B1, and B1 is this. So now I've got this equation. Very simple to solve this now. And when I do, I get H1 is equal to 60. Okay? So that's the first piece of the puzzle. We've got 2 more. We've got to figure out H2, and then we've got to figure out H3 in a very similar way. All right, let's move right along. The next relationship is between B2 and H2, and in a very similar way, using similar triangles, that's also going to be equal to 125 over 120, or 25 over 24, exactly how I did over here. Those are also going to be similar triangles. So this means that B2 is equal to 25 over 24 times H2. And then substitute that into this formula. This is equal to 1875. So I've got 1/2 B2, which is 25 over 24 H2, times H2 minus A1, which is 1875, is equal to 1875. So this becomes 3,750 is equal to H2 squared times 25 over 2 times 24. And when you do that math, you get H2 is equal to approximately 84.85. All right, one more to go. Now again, B3 and H3, and in a very similar way, that's going to be equal to 24 over 25 using similar triangles. That means B3 is equal to 25 over 24 times H3. And now we're going to use this formula right here. 1/2, sorry, this should be B3 here. 1/2 B3 times H3 minus A1 minus A2 is equal to 1875. 1/2 B3 25 over 24 H3 times H3 minus 1875 minus 1875. Put those over on the other side, and you will get 1875 times 3, which is 5625. And again, you do this math here, solve for this, pretty straightforward, and we get H3 is equal to approximately 103.923. All right, we are pretty much done with the question, because remember, I had to figure out that small h, so that is going to be h minus is equal to 120 minus H3. H3 I just got was 103.923 approximately. So that means h is equal to approximately 16.07. And of the answer choices, 16.07 is closest to E for number 23. Mohammed has 8 boxes numbered 1 to 8 and 8 balls numbered 1 to 8. In how many ways can he put the balls in the boxes so that there is one ball in each box? Ball 1 is not in box 1, ball 2 is not in box 3, and ball 3 is not in box 3. All right, well, we have to first a little bit of a primer that if you have, let's say, 8 possible choices, right? And I say to you, how many ways can you put 8 balls in 8 boxes without any restrictions? Well, for the first box, I've got 8 possible choices. For the second box, I've got 7 possible balls to choose from. For the next, I've got 6 remaining balls to choose from. 5, 4, 3, 2, 1. And then you have to multiply them all. And when you multiply them all, you get factorial notation. You don't have to write it in factorial notation. It's just a little bit easier, 8 factorial. And when you multiply it all out, of course, 8 factorial is equal to 40320. So throughout this question, I'm going to use factorial notation. And of course, most of you are familiar with that. But just in case, if you're not, it just means, 8 times 7 times 6 all the way down to 1. And that is something that if you're not familiar with, you definitely need to become familiar with. So that's the first thing. Okay, now let's put in a diagram and illustrate how we will approach this question. So this big S represents our entire universe here, and that in particular means the number of ways of placing the 8 balls without any restrictions. And this is, of course, the total number of ways, and like I had previously mentioned, that's going to be 8 factorial. Okay, so now let's talk about each of these letters here. A, this guy right here, which really talks about that circle. That circle is referring to the number of ways that ball 1 can be placed in box 1. So we need to talk about this. I can't just give you the answer without explaining it. The number of ways that ball 1 can be placed in box 1, well, if this is the first box right here, I'll put that ball 1 there. Okay, so there's only one way of doing that. And the remaining balls can be placed in the following way. I've got 7 choices for the next slot, 6 choices for the next slot, 5 remaining balls can be chosen for the next slot, and so on, right? So that's why you put here 7 factorial. Okay? B, that circle right here. That circle represents the number of ways that ball 2 can be placed in box 2. And in an identical way, it is also 7 factorial. Same explanation as to why. C represents that circle, and C is talking about the number of ways that ball 3 can be placed in box 3. And that is also 7 factorial. All right? So far, so good. No tricks. Just straightforward. Okay, so now we move on to the other letters. We have to start talking about the other letters and what each of those other letters represent. And in particular, we will look at this region right here, W plus Z. W plus Z is referring to any such situation where ball 1 is in box 1 and ball 2 is in box 2. All right, well, let's talk about that. Let's say we have 8 possible boxes, right? We put ball 1 in box 1. We put ball 2 in box 2. All right, those are fixed. There's only one way of doing that. Now we've got 6 balls left. We have 6 choices for the next, 5 for the next, 4, 3, 2, 1. And that it basically is 6 factorial. So this is 6 factorial. All right. And the next one is y plus z, these guys. Y plus z represents the number of ways of putting ball 1 in box 1 and ball 3 in box 3. And the way you calculate that is identical to the previous one. And then the final one is x plus z, and those are those guys. And x plus z represents the number of ways of putting ball 2 in box 2 and ball 3 in box 3. And that is also equal to 6 factorial. Now we have one little guy left, and that's z. And z needs to be considered, cannot be ignored. And z basically represents the situation where you have ball 1 in box 1 and ball 2 in box 2 and ball 3 in box 3. So z is the number of ways. Okay, we need to figure that out. Can't just give you the number. So there's 8, right? We put 1, 2, and 3. So those are fixed. That's what z is. And then there's 5 choices remaining of the 5 remaining balls. I can put 5 here. Any of the 5 there. Any one of the 5. And then I have 4 choices remaining for that slot, 3 choices remaining for that box, 2, and then 1. So this is essentially 5 factorial. Remember, don't get confused. Those are the numbers on the balls, okay? So those are fixed. 1, 2, 3 is fixed. So there's only one way of doing that. And then here, this gives me 120. So that basically is 5 factorial. All right, so now that was explained in detail, I hope. Now we can figure out what it is that we want. What it is that we want in this question is this little guy right here. We want scenario where we don't have any of these. All of these guys, we don't want them. So it would basically be small s would be the big S, the big universe, minus all of those letters, which is T plus U plus V plus W plus X plus Y plus Z. If I can figure that out, I'm done with the question. All right, I think I can do that. Instead of plugging it all in at once, it will become very confusing. So let's do this once a little bit at a time, one at a time. Okay, so first let's figure out what is this W plus Z. Well, we know what that is. That is 6 factorial. We figured that out. but I can use that to isolate for w. W, therefore, is 6 factorial minus z, but z is 5 factorial. So 6 factorial minus 5 factorial. In a very similar way, I can use the next equation, y plus z is equal to 6 factorial, to isolate for y, and that again is also 6 factorial minus z, which is 5 factorial. And also in a similar way, I can use x plus z equals 6 factorial to isolate for x. That's going to be 6 factorial minus z, which is 5 factorial. All right, so we got those ones all down. And now I have to figure out values for t, u, and v. Well, t plus u, or sorry, t, this circle right here that represented by a is t plus w plus y plus z, correct? And we had said that is equivalent to a, which is 7 factorial. So put that here, 7 factorial. Well, if I isolate for t, it will be 7 factorial minus w, which is this guy right here. So minus 6 factorial plus 5 factorial, right, when I subtract them. And then minus y plus z. And y plus z is 6 factorial. So minus 6 factorial. And in a very similar way, you can do the same thing to figure out u and to figure out v. They will be identical to that up there, using the fact that u appears in b and v appears in c. So same, no tricks, exact same thing. Okay, so now I'm ready to figure out this big long equation here. S, if you remember, was the full universe, so that's 8 factorial. And then this big long thing, t, is 7 factorial minus 6 factorial plus 5 factorial minus 6 factorial. And then u and v are exactly the same. So instead of writing them all out, I can just multiply all that by 3. And now we're looking at w and x and y, these guys here, and they're all here. W is 6 factorial minus 5 factorial, and y and z, or y and x I should say, are exactly the same. So I can just put a 3 out here, multiply those guys by 3. And then finally the z, well, that's just 5 factorial. So plus 5 factorial. All right. So now we have to just crunch these numbers out. This is going to be 40320 minus 3 times 3770 plus 3 times 600 plus 120. And when you do the math, you get 40320 minus 11160 plus 1800 plus 120, and that is all going to equal 27240. And that is your answer. 27,240 is choice A for number 24. Points P, R, S, and Q, T, U are on the parabola with the equation y is equal to x squared minus 1/5 mx plus 1/5 n, so that PQ equals 13 and the slope PQ is 12 over 5. For how many points Mn of positive integers with n less than or equal to 1,000 is R plus S plus T plus U equal to 27? Let's just draw a very brief diagram, and perhaps this parabola looks something like this, and we've got to choose 2 points here, P and Q. And when we draw a line from them, they're going to say that that slope is 12 over 5. So this is just to illustrate what that looks like. And therefore, we can now calculate using the points. P is RS and Q is TU. So using those 2 points, since the slope is equal to 12 over 5, we can use those 2 points to get a little equation. So U minus S over T minus R will be equal to 12 over 5. And I have no idea what is U and S and T and R, but I know the ratio. So that means U minus S must equal some multiple of 12, and T minus R is probably some multiple of 5, and that's how you get a ratio of 12 over 5. Okay? All right, so that's the first little piece of mathematics. Now the next thing is this piece of information right here, that the distance between P and Q is 13. So using the distance formula and those 2 points, we can find the following equation, that U minus S squared plus T minus R squared is equal to 13 squared, right? So I'm going to substitute these points in to figure out what K could possibly be. U minus S is 12K, square that. T minus R is 5K, square that. And I've got 169 here. So this becomes 144K squared plus 25K squared, and that is equal to 169. So this is now 169K squared is equal to 169. So that means obviously K is equal to 1. All right, great. So putting that back into these two guys, that gives me that U minus S is equal to 12, which would be giving me U is equal to 12 plus S. And then it gives me that T minus R is equal to 5, which would give me that T is equal to 5 plus R. So my 2 points now, I have P, R, S, and I have Q, T, U, but what I can do is I can put Q in terms of R and S, since I have these two relationships right here. That will allow me to put T as 5 plus R and U as 12 plus S. So there we go. That at least helps me a little bit. I can get rid of some of the variables, and now I can work with less variables, which is always better than more variables. Okay, so here we go. Now let's turn our attention to this part of the question. They want us to figure out a situation where R plus S plus T plus U is equal to 27. All right, but I know some really nice relationships here, so let's substitute those in. That T is equal to 5 plus R and U is equal to 12 plus S. So I've got R plus S plus T, which is 5 plus R, plus U, which is 12 plus S, is equal to 27. So this simplifies to 2S plus 2R is equal to 10, and therefore S plus R is equal to 5. So that's my first piece of information that is very helpful. Now both those points P and Q are on the parabola, so we can substitute those points into those parabola. So substituting, we get the following. We get the first equation, which would be substituting this point, and that would basically give me S is equal to R squared minus MR over 5 plus N over 5. And then substituting that one, we get a little bit more algebra there. We get S plus 12 is equal to 5 plus R squared minus M times 5 plus R all over 5 plus N over 5. And then when you expand this, you get S plus 12 is equal to R squared plus 10R plus 25 minus M minus MR over 5 plus N over 5. And then what we do now is we will subtract from 2 equation 1 and simplify. And when you collect like terms, you will get just 12 is equal to 10r plus 25 minus m. Simplifying and isolating for r, you get m minus 13 over 10 is equal to r. So this is my next helpful piece of information. Now I will take this very helpful piece of information and I will substitute it back into 1. Equation 1, that is, right here. And when I do and I put that in, I get m minus 13 over 10 all squared minus m times r, which is m minus 13 over 10. And then, of course, don't forget the 5 there. And then plus n over 5. Once you simplify this big, long thing, you get the following. You get s is equal to 1 over 100 times minus m squared plus 169 plus 20n. This is another very helpful equation. So, to summarize, we now have 3 very important equations that I have placed a star. We have s plus r is equal to 5. R, this guy, is equal to this. S here is equal to this. So I will put what I have for r there and what I got for s right there. So that's my next step. R plus s is equal to 5. So let's put r, which is m minus 13 over 10 there. S is over here. Let's put that over for the value for s. So it'll be 1 over 100 times minus m squared plus 169 plus 20n is equal to 5. Okay, so now we have to simplify this. And when you simplify, you get 20n is equal to m squared minus 10m plus 461. If you complete the square, you will be able to factor this very nicely. And you get 20n is equal to m minus 5 squared plus 436. All right. So now let's talk about this now. This is the equation that pretty much we're down to. This is our sort of final equation that we need to talk about and discuss and all that stuff. Well, 20n is obviously an even number. 436 is an even number. So that means this guy has to be even. And therefore, m minus 5 is even. And therefore, m is odd. Okay? So I hope that made sense. So since m is odd, I will let m equal to an odd form, which is 2k minus 1. Right? Any odd numbers of that form. And I will now substitute that back into this guy right here. All right? So substitute m is equal to 2k minus 1 back into my equation here. So when I do that, I get 20n is equal to 2k minus 1 minus 5 all squared plus 436. When you simplify and collect like terms, you get 20n is equal to 4k minus 3 squared plus 436. And I can divide through by 4, and that just gives me 5n is equal to k minus 3 squared plus 109. All right. Now recall that n in the question was given to us as being less than or equal to 1,000. So we can use that to help us out. And what I'm going to do is make a little table and try to figure out how can I make this equation here work. Well, we need to first consider values for k minus 3, then values for k minus 3 squared, and then of course the entire equation, which is k minus 3 squared plus 109. Now, k minus 3 squared plus 109 is equal to 5n. So that means that is a multiple of 5. And multiples of 5 end in either 5 or 0. All right? So, what I'm going to do is I'm going to place only the units digit into those boxes to figure out what my k can be. Well, k minus 3, whatever it is, the units digit is anywhere from 0 to 9, right? Those are all the possible units digits. Okay, if that is the case, when I square it, what happens? Well, the units digits then become 0, 1, 4, 9, 6, 5, 6, 9, 4, and 1. Okay, what happens when I add a 109? Well, then the units digits become 9, 0, 3, 8, 5, 4, 5, 8, 3, and 0. Well, which one of these end in either a 0 or a 5? This one, this one, this one, and this one. So that means that k minus 3 has to have a units digit of either 1, 4, 6, or 9. All right? Okay, so since my n is less than or equal to 1,000, don't forget about that, a very important parameter. That means that k minus 3 squared plus 109 is less than or equal to 5,000, since it's equal to 5n. Correct? So that means that k minus 3 squared is less than or equal to 4891 when you subtract the 109, and when you take the square root, you get k minus 3 is less than or equal to 69.9. But remember, k is an integer. So k minus 3, I should say, has to be less than or equal to 69. K minus 3. Now we have to talk about what values of k can I plug in that will give me units digits of either 1, 4, 6, or 9. Correct? And keeping in mind that k minus 3 is less than or equal to 69. So I got 72, 69, 67, 63. If you notice, if these are k's, k minus 3 will equal numbers that give these as the units digit. Okay, that's what I'm doing. So continuing, I get 62, 59, 57, 53. You'll see that there's a pattern here. 52, 49, 47, 43, and so on, right? So I'll just fill them all in. And there you go. There's my entire list, where k minus 3 is less than 69. And I'm choosing values of k so that k minus 3 will have a units digit of either 1, 4, 6, or 9. And how many did I create in total? If you add all those up, it's 29. And each value of k from this list of 29 will give one value of m, because if you recall, m is equal to 2k minus 1. And then once you have a value of m, you plug it back into here to get a value of n. So each of these 29 values of k will give a value of m and a value of n. Therefore, that would give me 29 pairs of the form mn. And that is the answer to the question, 29. So that would mean that number 25, the answer is D.